Welcome back. We started solving this question in the previous video and we solved the first four parts. So we have solved A, B, C, and D. In this video, we are going to solve the last part, which is E. So let's begin. The last part says that we should draw the image triangle A3, B3, C3 of triangle ABC under a clockwise rotation of 90 degrees about the point 1, 2, where A maps to A3, B maps to B3, and C maps to C3. So we are going to draw the triangle A3, B3, C3, which is the image of the triangle ABC after it has been rotated through a 90 degrees angle in the clockwise direction about the point 1, 2. So you take note of this. This time we are not rotating the points about the origin. We are rotating it about the point 1, 2. And it says that point A will give us A3, point B will give us B3, and point C will give us C3. So we are going to rotate the point A through a 90 degrees clockwise angle about the point 1, 2 to get A3. We will do the same thing to B to get B3. Then we do the same thing to C to get C3. So let's do that. We have learned that under a 90 degrees clockwise rotation about the origin, the rule of the transformation is xy will give us y minus x. But remember that this time we are not rotating the points about the origin. We are rotating it about the point 1, 2. We have already learned how to rotate a point in the xy plane about another point other than the origin. So we are going to apply that here. The points we are going to rotate are point A with coordinates 6, 2, point B with coordinates 2, 2, and point C with coordinates 2, 8. So let's begin with point A with coordinates 6, 2. We have learned that in order to rotate a point in the xy plane about another point other than the origin, we will do that in 3 steps. The first step is that we will subtract the center of rotation from the point to be rotated. The center of rotation here is 1, 2. We are beginning with point A with coordinates 6, 2. So the point we are rotating is 6, 2. And the center of rotation is 1, 2. Our first step is that we have to subtract the center of rotation from the point to be rotated. So you subtract 1, 2 from 6, 2. So we have 6, 2 minus 1, 2. 6 minus 1 will give us 5. 2 minus 2 will give us 0. So after subtracting the center of rotation from the point to be rotated, we are having the point 5, 0. The second step says that we should rotate the resulting point in the direction given and the angle given about the origin. The angle given is 90 degrees and the direction is the clockwise direction. So it means that we are going to rotate the point 50, 90 degrees in the clockwise direction about the origin. We have learned that when we rotate a point 90 degrees in the clockwise direction about the origin, the rule is xy maps to y minus x. So we are going to use this rule to rotate the point 50. Using this rule, when we rotate the point 50, we are going to get the image 0 minus 5. Now after that, the third and final step says that we should add the center of rotation to the result in step 2. The result in step 2 is the image here, which is 0 minus 5. So we will add the center of rotation, which is 1, 2, to 0 minus 5. That will give us 0 minus 5 plus 1, 2. 0 plus 1 will give us 1, minus 5 plus 2 give us minus 3. So it means that under a 90 degrees clockwise rotation about the point 1, 2, the point A with coordinates 6, 2 will give us the image A3 with coordinates 1, minus 3. So this is for point A. We are going to do the same thing for point B and point C. So let's do that. Point B has the coordinates 2, 2. We are going to rotate point B through a 90 degrees clockwise angle about the point 1, 2. The first step is that we should subtract the center of rotation from the point to be rotated. The point to be rotated is 2, 2, and the center of rotation is 1, 2. So we have 2, 2 minus 1, 2, and that will give us 1, 0. After that, we will use this rule to rotate the point 1, 0. When we use this rule to rotate the point 1, 0, we will have 0 minus 1 as the image. So after we have subtracted the center of rotation from the point to be rotated, we will rotate the resulting point in the direction and the angle given about the origin. So we rotate 1, 0 in the 90 degrees clockwise angle about the origin. And when we rotate 1, 0 in the 90 degrees clockwise angle about the origin, we will have 0 minus 1. Then the third and final step is that we should add 0 minus 1 to the center of rotation, which is 1, 2. So we have 0 minus 1 plus 1, 2. 0 plus 1 will give us 1. Minus 1 plus 2 will give us 1. This means that when we rotate the point B with coordinates 2, 2 through a 90 degrees clockwise angle about the point 1, 2, B with coordinates 2, 2 will give us B3, which is the image of B, and it will have the coordinates 1, 1. We will do the same thing to point C. Point C has the coordinates 2, 8. So the first step is that we will subtract 1, 2, which is the center of rotation, from 2, 8. 2, 8 minus 1, 2 will give us 1, 6. Then after that, we will rotate 1, 6 through a 90 degrees clockwise angle about the origin using this rule. So using this rule, 1, 6 will give us 6 minus 1. After that, we will add the center of rotation, which is 1, 2, to 6 minus 1. So we have 6 minus 1 plus 1, 2. 6 plus 1 will give us 7, minus 1 plus 2 will give us 1. So it means that when the point C with coordinates 2, 8 is rotated through a 90 degrees clockwise angle about the point 1, 2, point C with coordinates 2, 8 will give us C3 with coordinates 7, 1. So we now have the coordinates of A3, B3, and C3. We can plot them on the graph sheet now. So we are going to plot A3, B3, and C3. The coordinates of A3 are 1 minus 3. So 1 on the x-axis and minus 3 on the y-axis. That will be here. The coordinates of B3 are 1, 1. So 1 on the x-axis and 1 on the y-axis. And that will be here. And the coordinates of C3 are 7, 1. So 7 on the x-axis and 1 on the y-axis. That will be here. After that, you join these points to form the triangle A3, B3, and C3. Let's write the names of each point against it. So this is point A3 with coordinates 1, minus 3. This is point B3 with coordinates 1, 1. And this is point C3 with coordinates 7, 1. We have now solved the question we started in the previous video. So we started this question by drawing the triangle ABC. Then we rotated triangle ABC through a 90 degrees anticlockwise angle about the origin to get triangle A1, B1, C1. Then after that, we rotated triangle ABC again through a 180 degrees angle about the origin to get triangle A2, B2, C2. Then finally, we rotated triangle ABC again through a 90 degrees clockwise angle about the point 1, 2 to get a triangle A3, B3, C3. Now you can see from here that when we rotate the triangle, the size and shape of the triangle does not change. It only changes in position. So the size and shape of triangle ABC is the same as the size and shape of triangle A1, B1, C1. is the same as the size and shape of triangle A2, B2, C2, and the same as the size and shape of the triangle A3, B3, C3. So the only thing that changes here is the position. In the video on Introduction to Transformation, we learned that when an object undergoes a rigid motion, it only changes in position. Its size and shape does not change. So from here, we can say that rotation of an object in the XY plane is an example of a rigid motion, because when you rotate an object in the XY plane, it doesn't change in size and it doesn't change in shape. It only changes in position. In the video on Introduction to Transformation, we said that in this topic, we will consider 4 types of transformation. So far, we have considered reflection, translation, and rotation. In the next video, we will learn about enlargement. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn about how to enlarge an object in the XY plane. Bye-bye.